IP version 6. And you are going to see in today's class why version 4, we're moving to IP version 6. So look at it here. The need for IPv6. On top of it, they wrote IPv4 issues. So why are we trying to migrate to IP version 6? And why do we need to learn IP version 6? Or you need to know about IP version 6? IPv4 is running out of addresses. When I say IP version 4 is running out of addresses, I am referring to public IPv4. Public IPv4. Because of the explosion on the internet, the way the internet has become very, very popular, more people are connecting, more things are being connected. The public IP addresses, IPv4 addresses that we spoke about has finished already. In fact, they have finished. How do we connect new set of people to the internet? We need more IP addresses, and we can't get more from IPv4. That's why the world is now moving to IP version 6. I heard that China has moved completely to IP version 6. The rest of the countries that have not moved to IP version 6 are still using IP version 4. So the migration is going to be gradual. Gradually, we're moving gradually to IP version 6. So you need to learn IPv6. That is one of the reasons why it is in the curriculum. The complete implementation may not be in the next 5 years. It may not be in the next 10 years. But the way schools do their things, by the time they will start implementing all over the world, everybody have known about teaching you gradually. They will start teaching you gradually. They will start teaching you gradually. So that is the way schools do their things. Just a minute, guys. Hello, guys. Can you hear me? If you can hear me, so let's fire on. All right, good. So until we sort out this issue of power, that's when I can power my Starlink. So sorry, guys. So sorry about that. Yeah. So I said IPv4 addresses is out already. Not that it's trying to go out. It has finished already. So how are we going to connect other people that need internet access? That is the reason for IPv6. So the world is moving gradually away from IP version 4 and moving to IP version 6. So this is one of the reasons why we have to learn IP version 6 in today's class. So you see what they are saying there. IPv4 is running out of addresses. It's out already, not even running out. So what they are currently doing now is they collect from people that have used or have migrated to IP version 6. They collect their own IP version 4, public IP version 4 addresses, and use for new people coming up that don't have that are yet to the region that are yet to migrate to IP version 6. And look at the difference between IP version 4 and IP version 6. One of the differences. IPv6 has 128-bit address space, unlike IP version 4 that has 32-bit address space. So you see the difference. You are going to see the structure as we proceed. The development of IPv6 is also included fixes for IPv4 limitation and other enhancement. So one of the things they did with IPv6 was that they look at IPv4. What are the mistakes or what are the things they thought should be there that were not there? They fix all of those things in IP version 6. So right now, because of Internet of Things, whereby all your things are going to be on the internet, we just have to move to IP version 6, and the world is gradually moving to IPv6. So you're going to see more about this. So how do we manage the situation for now? Both IPv4 and IPv6 have to coexist for now. This is one of the things I like with the Western world. They are very strategic the way they roll out things, the way they migrate. They will allow things to go to die a natural death. Let me give you an example. If you have a car that you feel like, I don't want to part with this car till death do us part, you are going to be the one to leave that car alone when you cannot get the parts again, when you cannot replace some things again. So the car will die a natural death in your hand. So they allow the whole technology to run concurrently with the new technology. When you don't have equipment that can run on the old again, on the old those things or the old technology again, you will just have to migrate to the new technology. Or when you see the benefit of the new technology, you just have to migrate. So for now, IPv4 and IPv6 are now going to be coexisting, or they are currently coexisting. What I mean by that is this: countries that are running IPv6, they can talk to us that are running IPv4, and vice versa. And there are technology to make that happen. And I'm going to just summarize this technology. Both IPv4 and IPv6 will coexist in the near future, and the transition will take several years. The transition is already happening. It's already happening. And we have different technology to make both of them to coexist. The first one is called dual stack. Dual stack. And you are going to, one of the assignments you're going to do, the labs you're going to do, you're going to configure IPv4 and IPv6 simultaneously on your router. And both of them must work. You test the network based on IPv4. You test for connectivity. You test for the connectivity based on IPv6. So when you run the two of them concurrently, that technology is referred to as a dual stack. The devices run both IPv4 and IPv6 protocol. So what is the point in running the two? You are not sure if you know about your IPv6 will work, or probably you have not mastered this IPv6 stuff. So if you run the two concurrently, when you are done doing all your testing, if you know that, okay, IPv6 is now working, you can get rid of IPv4 on that network. So, but you can run the two simultaneously for the start, then later on you can get rid of IPv4, because that is the essence of You want to run the two. When you are sure that the new is working, you get rid of the old. So one of the ways we can get this done is by doing dual stack. Another technology to get this done is called tunneling. Tunneling. I have a lot to say on tunneling, but not in this class, or not within the context of this curriculum or this course. It's a method of transporting an IPv6 packet over an IPv4 network. Case in point, let's say your service provider is still running IPv4 and you have moved to IPv6. You are the client in your organization. You move to IPv6. You can carry the IPv4 over IPv6 network. No problem. So how will this network or this service provider network understand IPv6 packet? The technology to make them work together is called tunneling. Tunneling in a sense is when you pass something through a tunnel. We're not seeing it outside. So by the time the IPv6 packet gets to the IPv4 network, it will be passing through IPv4 network as if it is IPv4 by itself. And this is different from translation. They sound alike, or the explanation sounds alike, but they are two different things. So tunneling is a technology for us to make IPv4, IPv6, and IPv4 network to coexist as well. And there's no for you guys, and you just need to know all of this technology by heart. And the last technology to use in this course that we're going to be discussing for coexistence between IPv4 and IPv6 is translation. It is called NAT64, Network Address Translation 64, meaning we're translating from IPv6 to IPv4. Network address translation, we are translating from IPv6 to IPv4. This is different from tunneling. We have a similar technology in IPv4. That one is just NAT, whereby we translate from private IP address to public IP address. I've mentioned that before. So when you want to go to the internet, NAT is a technology we implement on our router, and we have a topic on this, a whole chapter on this, where you translate your private IP address. Your router does that for you. It translates your private IP address to public IP address so that you can browse the internet. But in the case of IPv6, when you are trying to do this coexistence issue, we have NAT64. So what happens is the technology allows IPv6 packet to be translated to IPv4 and vice versa. Mr. Uche, you are back. You are welcome. You are welcome. I'm happy to see you. So these are the technology, but the one we use majorly in CCNA is dual stack, whereby you run the two of them concurrently. We're not translating. IPv4 network is working, everything is working, and then IPv6 is working concurrently. That is dual stack. We use that in CCNA a lot. The others can be implemented at the advanced level if there is a need for them. But don't forget, all of this technology we are talking about, they are just for transitioning to the real IPv6 network. So we are going to come to a level whereby everything is IPv6, no more IP version 4. You need to be aware of that. So even though we are discussing technology that can help them to coexist, that is just a temporary fix. A time is coming when everybody must be on IPv6. And I have another chapter dedicated to IPv6 in CCNA too. When we come to that, you're going to see. So we're just going to talk based on what is in this chapter. So let's talk about the format of IPv6. Just the same way I taught you guys about IPv4. When you see an IPv6, you should be able to break it down. You should be able to analyze it. So how does IPv6 look like? What are the things you need to know about IPv6? I like this slide here, guys. I have taught you guys binary, decimal to binary, binary to decimal, hexadecimal to binary, hexadecimal to the decimal, all kinds of conversion. If you don't understand hexadecimal, you cannot understand IPv6. Why? IPv6 is not written in decimal, it's written in hexadecimal. That was one of the reasons why we did what we did. IPv6 address is written in hexadecimal. And you're going to see as we proceed. So to understand the IPv6 address, you must be able to convert hexadecimal to decimal and vice versa. We have done that already. And hexadecimal is what? A base 16 numbering system. We've talked about that. So why are we using hexadecimal? Because the number is big. That is, the IPv6 address is big. The best way for us to kind of write it out is to use hexadecimal, because hexadecimal will help us to shorten some of these things. It is easier to express a value as a single hexadecimal digit than a 4 binary bit, which you see in this place. Look at these binary digits now. Look at the equivalence in hexadecimal. Look at this binary digit. Look at the the equivalence in hexadecimal. So we find it easier writing in hexadecimal than writing the binary. And don't forget, I've said, when you write decimal, computer is not in decimal, it's in binary. Okay, it's the same thing with hexadecimal. So if we put our IP address on the computer in hexadecimal, I'm talking of IPv6 right now, computer is not seeing all of those hexadecimal values, it's saying binary digits. That's why we did all of those conversions. So look at the last statement here. Hexadecimal is used to represent IPv6 addresses, and of course MAC address. We've talked about this one before. So we want to go to IPv6 address, and you see how we use hexadecimal to depict that. Let me show you something before we continue. Let me show you something. Let me go to command prompt and ping, say www.google.com. I hope it will reply with IPv6. Yeah, good. It replied with IPv6. So you can see Google replied me with an IP address. Look at the IP address here. If you take a look at this right now, if you have not taught you IPv6, you get lost. You'll be wondering, what is this one now? Is this Latin? Is this Chinese? Is this Korean language? No, hexadecimal. And so at the end of this class, you'll be able to analyze this address. Because all of those servers out there, or websites that you know, they all have IPv4 addresses, and they all have IPv6 addresses, because they got to get rid of IPv4 with time. Let's ping facebook.com. Look at Facebook. Facebook is also replying me with IPv6. Look at Facebook's IPv6 address. One off. There are numerous, because there are different servers all around the world. So when you see this, you must be able to analyze. So we're going to come back to this place later, but I just need you guys to see a good example of an IPv6 address. So IPv4, subletting. You will soon get hold of. What I mean by that will soon be in the past. But we may not be alive. It may not be in our lifetime. Maybe it's in the next 20, 30, 40, 50 years that the world will now completely migrate. Maybe it's our kids that will be using IPv6 fully. And even at that, if you look at my computer, if I see ipconfig, we've used that before, /all, you go to see IPv6 address. Look at my wireless. It also has an IPv6 address. Look at the IPv6 address on my computer here. How did my computer get this IPv6 address? We're going to come to that. Not today, in another class. That's one that I said is another chapter dedicated to IPv6. Well, I'm going to also demonstrate IPv6. So this is non-negotiable for you guys. So my computer has two IP addresses. It has IPv4 address and also has an IPv6 address. This is my computer that I'm using, because that's the world is going towards that gradually. And we need to learn all of this. So guys, let's break down IPv6 address and see how it looks. How did they arrive at all of those things, or how we can be able to analyze same concept, just a different value. The other one we're using decimal. This plane we are using hexadecimal. So let's fire on. IPv6 addressing format. IPv6 address are first key 128 bits in length and is written in hexadecimal. IPv6 addresses are 128 bit in length and written in hexadecimal. IPv6 addresses are not case sensitive. You can write the hexadecimal in any number or any letter. or combination. So you can write in lowercase, you can write in uppercase, no shaking. Now listen, guys. The preferred format for writing an IPv6 address is this: x colon 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 x. If you can't guess, that will be 12. 1, 2, that's it, 12. I think it's 4 times 128. 4 times what? Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8. Sorry, 8. With each x consisting of 4 hexadecimal values, guys. So this x thing I'm talking about right now, each of the x we give will be 4 hexadecimal values. So when you want to say 4 hexadecimal value, what do I mean? Pick 4 letters or numbers or combination from the hexadecimal. If I say A, B, C, D, they are part of hexadecimal. If I say coffee, they are part of hexadecimal. I can get those numbers from hexadecimal. Look at it here. C, A, F, E. That's 4 hexadecimal digits. I can say 1, 2, 3, 4. It's hexadecimal digits. I can mix them up. It's hexadecimal digits. I can say ABC. It's hexadecimal digits. So each of the x that we're talking about here, each of the x consists of 4 hexadecimal values. Each of the x. So let me give you an example. I can start the first x and say it's ABCD colon. The second x, let's say dad, DADE. The next one colon, cafe. The next one colon. You can form words out of those things. Let's say 1, 2, 3, 4. The next one colon, 5, 6, 7, 8. The next one colon, that is 1, 2, 3, 4, 5, 6. The next one colon, let's say 1 ABC. The next one, which should be the last one, it should be 8. 1, 2, 3, 4, 5, 6. We have 2 left. Let's say BCAD. The next one colon AB, maybe AB. And that is it. This is how IPv6 address is going to look like. It must be 8 hexed. That's another thing you need to understand. 8 hexed. In IPv4, we call each of those boxes octets. Octet. But in IPv6, each of these boxes, we call them hexed. And each of the hexed we have 4 hexadecimal value, while each of the hexadecimal digits is 4 bits. You guys know that already. A is 4 bits, B is 4 bits, C is 4 bits, D is 4 bits. Each of the hexadecimal digits is 444 bits. By the time you multiply 4 by 4, it means each of the hextets will give you 16 bits. And by the time you multiply 16 by 8, because there are 8 of the hextets, that will give us 128. That's why they arrive at 128 bits in length. That is how your IPv6 address look like. Now you said I just pick a number anyway, anyhow. That is just for the purpose of explanation. As we proceed, you're going to see what should be in the first hextet, where is our network portion, where is our host portion, because it's the same concept. It's the same concept with IPv4. It's the same concept. Just that the numbers are different. One is decimal, the other one is hexadecimal. One is 32-bit, the other one is 128-bit. One is separated by dot, that's IPv4. IPv6 is separated by column. You can see column, column, column everywhere. I'm not saying dot, 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 dot. No. It's column, 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 and so on and so forth. So take a note of that, guys. So the preferred format for writing IPv6 is, I've explained this right now. You're going to have 8 hextets, and each of the hextets will be 4 hexadecimal value. In IPv6, a hextet is an unofficial term used to refer to segment of 16 bits, because in each of the hextets there will be 4 hexadecimal values. 4 hexadecimal values. And look at another example. They gave us their own example. Example of IPv6 address in the preferred format. Look at one here. 2001 colon 0db8 colon 0000 colon 11111 colon 00000 colon 0000 colon 0000 colon 0200. Is it complete? This is the first extent, the second one, the third one, the fourth one, the fifth one, the sixth one, the seventh one, the eighth one. So I have my complete IPv6 address. If we go back to command line and you see the Google address, IPv6 address, you can see that it's the same thing. You may not understand now. Let me finish this thing before I come back to Google, because we are going to learn how to summarize IP. So this is just a good example of IPv6 address. This is another example. As long as you combine all those hexadecimal digits, you have them in 8 places. Each of the X's 4 hexadecimal digits. Mind you, this will give you, yes, I'm recording, Mr. Samuel, thank you. This will give you 16 bits. This will give you 16, I say 16 bits, 16 times 4. 16 bits, 4 times 4 are 16 bits. This will give you another 16 bits. This will give you another 16 bits, another 16 bits, another 16 bits, another 16 bits, another 16 bits. Why? Each of the value, hexadecimal value, is 4 bits. Look at it again in our table. One hexadecimal value, 4 bits. Another hexadecimal value, 4 bits. Another 4 bits. So if I have 1, 2, 3, 4 now, that will give me 16 bits. And this will be equivalent to an hextet, colon, something else, colon, and so on and so forth. So this is their own example. So I believe we have been able to establish that it is 128 bits, 16 times 8, we have 8 hextets, and that's how IPv6 address looks like. Thank you, guys. That's how it looks like. But is there a way we can summarize this? Yes, we have a way to summarize this. After showing you that, then we can now go back to my command line, then I will show you Google address. Let's analyze it together. Like this long one they gave us here now, is there a way we can what do you call it? We can summarize it. Yeah, we can summarize it. Let's find out how to do that. There are 2 ways to summarize IPv6, 2 rules actually. The first rule is called omit leading zeros. Omit leading zeros. Please take note of that. Pay attention to details here now. Omit leading zero, not trailing zero. The first rule to help reduce notation of IPv6 address is to omit any leading zeros. Example, 01AB. This is an hextet. You can also represent it as 1AB. What happened? You can omit the leading zeros. The router will take it. The switch will take it. As a matter of fact, if you go to any of your router or switch and put 01AB, it will automatically summarize it for you to 1AB. And if you go to any router and also write 1AB, the router knows that there is O. There is 0 rather, not O. There is 0 before that 1AB. So because of this omitting the leading zeros. Look at another example here. 09F0. You can represent it as 9F0. What happened? You omit the leading 0. So if you go to any device and just put, that device knows that you have omitted the leading 0. It's a law, it's a rule law everywhere. Look at another example here. 0A00. It can also be written as A00. Look at another one here. 00AB can also be written as AB. So if I wrote AB now and put it on my router, the router knows that it is 00AB because of the leading 0. Take note, not the trailing 0. The trailing is one after. So if you have something like this, AB 00, you cannot write it as AB. That rule does not apply to the trailing 0. It only applies to the leading 0. So we can use this law to, this rule rather, to summarize our IPv6 address. Take note, guys. Look at the example here. 2001 colon 0, take note, DB8 colon 0000 colon 11111 colon 0000 colon 0000 colon 0000 colon 0200. This address you are looking at here, we can as well summarize it. And that is what they got in this place. How did they summarize that? they kill the first leading zero here. 2001 colon DBH. When they got to this one with 000, they kill all the leading zeros. They got 0 alone. Of course, 1 has to come down as 1111. Then this other one here, they kill the leading 0. There are 3 leading 0, they killed it. 3 leading 0, they killed it. You can omit this. 3 leading 0, you can omit it. And then the last one, you omit the leading 0. So this address you are looking at and this address here, they are the same thing. If you like, go on your router, put this address. By the time you go to the output of show, this is what you're going to see. So I can go out to my router and put this address, or to my switch and put this address. The router will accept it, and the router knows that I have omitted the leading zeros. Because the router knows that the IPv6 address is supposed to be 128 bits. And if it's calculating and it's not up to that, it knows that I've applied the rules of the leading zeros. Take note of that, guys. Omit leading zeros. Omit leading zeros. We can use that rule to shorten our IPv6 address if it is applicable. If you don't have any zeros anywhere, any leading zeros anywhere, then that rule is useless. But the moment you have leading zeros, you can apply the rule. Take note of that. There's another rule, guys. There are just 2 rules. Double column rule. How do we use this one? A double column, which is colon, take note, can replace any single contiguous strings of 1 or more 16 exits consisting of all 0. When they say contiguous strings, they are talking of zeros that follow themselves. So if you have something like this, 2001 colon 1234 colon 1234 colon 1234 colon 1234. These are contiguous strings of zeros. So 1, 2, 3, 4, 5. Let me put it colon 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. In fact, let me add another one. This address you are looking at now, I can summarize it as this 2001 colon. What did I do? All these zeros that follow themselves, I have used colon to summarize them. That is called single contiguous strings of zeros. They follow themselves all through. So if you see address like this, 2001 colon, and you see this long one like this, they are the same thing. What did we do? We use colon to summarize. And you can use this rule only once, guys. What do I mean by that? What if you have a scenario like this? Let me give you another scenario. You have a scenario like this, 2001 colon, let's say 0000 colon 0000 colon 1111 colon 0000 colon 0000. Let's say this is 1, 2, 3, 4, 5, 6 colon. Let's say ABCD colon 1111 1, 2, 3, 4, 5, 6, 7, 8. Now look at it now. I have contiguous strings of zeros here. I have contiguous strings of zeros here, zeros that follow themselves. If I want to summarize this address right now, how will I summarize it? You cannot come down and say 2001 colon 1111 colon ABCD, then colon 111. Now, this cannot work. You can only use this colon once in an IP address. So you decide whether you want to use it on the left or you want to use it on the right. So this address, I can summarize it this way. 2001 colon 1111. Then apply the first rule on the other side, the rule of leading zeros. Colon 0 ABCD colon 1111. What have I done? I apply second rule on the left here. I apply the first rule on the right. And I can reverse it the other way. I can write this address also like this, 2001 colon 0 1111 colon ABCD colon 1111. This address and this address are the same thing. So you cannot use that rule of double colon twice in an IP address. You can only use the rule of double colon once in an IP address. Please give me a thumbs up if I'm communicating. You can only use it once. Thank you, guys. I'm going to give room for question. Pause this thing, give room for question, then we'll finish the remaining part. So whenever you see an IPv6 address, you should be able to analyze the IPv6 address. Thank you. So let's go back to our command line and try to analyze what we got on our command line. So back to our command line, let me ping Google. See, Google is replying to me. Look at Google's one of Google's IPv6 address, guys. Look at what I got. 2C0F colon FB 50 colon 4003 colon A01 colon 2004. If you take a look at this address right now, it will look as if it's not complete. But because of the colon inside, those colon you see, that means there are contiguous strings of zeros that will make it to be 8 hextet. If you count the one that you see now, 1, 2, 3, 4, 5, there are 5 hextet. That means there are 3 contiguous strings of. In fact, let me see if I can write this thing out. Oh, my writing pen does not work on this command prompt. Let me write it out on paper and show you how it's supposed to be on my PowerPoint. 2C0F FB50 colon 4003 colon 801 colon 204. Okay, so let me analyze this address now. Let's write it out and analyze it. So the address we see is 2C0F colon FB50 colon 4003 colon 801 colon 2004. So if we want to expand this address, what are we going to have? Of course, you see 2C0F, our 4 hexadecimal digit is completed there, colon FB50 is completed, colon 4003 is completed, colon, if you look at the next hexet, it's not completed. Why? They have omitted the leading zero, so I can now put 0A01. When you saw colon in between, colon 0000 colon 0000 colon 0000, then colon 2004. This is the IP address that was summarized into this. This is the IP address that was summarized into this. So you need to take note of that. So whenever you see any IPv6 address, you should be able to analyze it. So if I count this now, 1, 2, 3, 4, 5, and I see colon inside here, that means there are 3 hextets of contiguous zeros that were summarized in between there. Let's pick Facebook's owners and analyze it. I also ping Facebook. So I'm going to write out Facebook's on how to. Maybe it was summarized. I will see. So what I have on Facebook is 2A03 colon 2880 colon F138 colon 83 colon face colon B006 colon 0 colon 25DE. So let's analyze Facebook's IPv6 address and see whether they summarize it or not. The address is 2A03 colon 2880 colon F138 colon 83 colon face colon B00C colon 0 colon 25DE. So let's count the hexet, guys. 1, 2, 3, 4, 5, 6, 7, 8. So they didn't use colon. Our extent is completed. But if you take a look at this one is completed, 4 hexadecimal digits. This one is completed. This one is completed. But look at this one here. What did they do? They use the rule of omitting the leading zeros. So this one should have been 0083. Take note of this one. The second one is complete. The next one is complete. The next one is completed. Look at this one here. They also omitted 3 leading zeros. This one will have been 00. So by the time you want to write this out, it will be 2903 colon 2880 colon F138 colon 0083 colon space colon B00C colon 0000 colon 25DE. This is the address that was summarized to become this. So whenever you see an IPv6 address, you must be able to analyze it, guys. That is the summary. So let's look at their own example and we'll leave this one alone. So look at their home, 2001 colon 0db8 colon 000 colon 1111 colon. Look at all these contiguous 00 and look at this one. So what did they do? 2001, see it here, colon db8, they kill this one, colon, they kill this, they kill this, they kill this. That's why we have colon 0, then colon 111, and then they apply that second rule here because it's a contiguous string of 0, colon colon, then they kill this 0 here for us to have 2 colon colon 20. This address is compressed and this is where it was compressed from. So whenever you see an IPv6 address, you must be able to break it down. I hope that is clear, guys. I'm going to give room for questions. Just give me, let's take like 10 minutes break. 10 minutes break. Thank you. Different addresses under IPv4. We also have some addresses we need to talk about under IPv6. And they are called, oh, sorry, I said I was going to give room for questions. Let me give room.